Today, we're going to learn the absolute basics of programming. But forget the dry, boring theory. We're going to do it by telling a story. A story about a little robot taking his very first steps.
So our story starts right here, in this totally empty, predictable world. Think of it like a blank canvas, the perfect place for us to start building something new.
And here he is. This is our hero, Hubo. He's a brand new robot, a total blank slate. He knows absolutely nothing. But that's okay, because we're going to teach him everything he needs to know, one step at a time.
Okay, so first things first. To get started, Hobo needs a way to interact with his world. We're going to teach him how to get around using just two, and I mean only two, incredibly simple actions. These two commands are the only tools in his toolbox. Hubo move.move, that takes him 1 block forward, and hubo.turnLeft, that just pivots him 90 degrees to the left. That's it. That's his entire vocabulary. Every single complex thing we want him to do has to be built from just these two basic ideas. And check this out. We write one line of code, hubo.move, and we see one clear result. He moves 1 step. This direct link, this cause and effect between instruction and outcome, is the absolute heart and soul of programming. All right, so Hubo can move and he can turn. Pretty basic. But what happens when we start stringing these simple commands together? Well, we get to create his very first program. So let's say we want him to walk in a simple square. All Hubo has to do is repeat the same 2 steps 4 times. Move forward, turn left. Move forward, turn left. You get the idea. This is a sequence, and it's our first fundamental concept of programming. Instructions are followed in order, one right after the other. And look at that. It works perfectly. This really shows you the power of that idea. A simple, ordered list of instructions creates a totally precise and predictable result. We told him to make a square, and that's exactly what he did.
But, in programming, just like in life, things don't always go exactly to plan.
Yep, crash. If we give Hubo a bad instruction, like telling him to move forward when there's a wall right there, the whole program just stops. We call this a bug, and honestly, a huge part of learning to code is just getting really good at finding and fixing these bugs.
Okay, Hubo is getting the hang of things, but writing out every single move and turn is it's getting kind of tedious. I think it's time we give him a bit of a mental upgrade.
I mean, think about this for a second. Hubo has no command to turn right. The only way we can make him do it is by telling him to turn left 3 times. Imagine typing that out every single time you want to make a right turn. It's clunky, it's repetitive, there has to be a better way. And of course there is. We can actually bundle those 3 turn left commands together and give them a brand new name, like turn right. This brings us to our second big concept, abstraction. We're creating a new, simpler command out of old, basic ones. Now, what's so crucial here is that we've hidden the complexity. We don't have to think about 3 left turns anymore. We can just say, turn right, and Hubo just knows what to do. It's literally like we've taught him a new word. But wait, we can make this even cleaner. Instead of writing hubo.turnLeft 3 times inside our new function, what if we could just tell the computer, hey, repeat this action 3 times? This is our third key concept, repetition, and we do it using something called a loop. So a loop is basically your best friend for automating repetitive tasks. It just saves us from writing the same code over and over again. Okay, so now Hubo can create new commands and he can repeat things. He's ready for the next big step, making his own decisions. So far, Hubo is a pretty good little soldier. He just blindly follows our orders, doing exactly what the sequence tells him to. But now, let's teach him how to think for himself. We can give Hubo the power to ask a question. Using what's called an if-else statement, he can check the state of his world and then act based on the answer. For example, if the way forward is clear, then move. Otherwise, else. Turn left. This is our final core concept, conditionals. And look at the result. This is a massive leap forward. With this one simple rule, Hubo can now navigate along any wall without ever crashing. He's not just following a rigid script anymore. He's actively reacting to his environment. This is huge. So we've taught Hubo about sequence, abstraction, repetition, and conditionals. Now it's time to put it all together. Let's combine everything we've learned to solve a much bigger, much more complex problem.
This elegant bit of logic you see here is a classic wall-following algorithm. The rule is actually really simple. Always try to keep a wall to your right. So if you can turn right, do it. If you can't, but you can go straight, then go straight. And if both of those are blocked, well, turning left is your only option.
And just watch this. By applying that one simple set of rules over and over again, Hubo can now navigate a whole complex hurdle race. We didn't program him to jump each specific hurdle, he's just following the wall. And that simple strategy gets him through every obstacle. And this is the magic moment. The really crucial point here is that the exact same algorithm we used for the hurdles also allows Hubo to solve this complex maze. We didn't change a single line of code. A simple, elegant solution for one problem can often solve other problems you never even saw coming. So think about it. We started with just two simple commands, move and turn left. And from there, we built up a sequence of simple rules that let a robot solve a maze. This whole process, that's the power of computational thinking. It's just breaking a big, messy problem down into small, manageable steps. And now, that's a power you understand.